Hi, welcome to Cloud with Previn. In today's session, we are diving into AWS networking. We will build out a VPC step by step, set up the subnets, route tables, and gateways. Then we're going to put it all together into a two-tier architecture with EC2 and RDS. By the end of this video, you'll see how these pieces connect to create a secure and scalable setup in the cloud. It is very important that you understand what is a VPC. A VPC is your own private network in AWS. It allows you to build a virtual network. You define the CIDR block and split it into subnets for application, databases, or services. Route tables and gateways decide how the packets move between them or out to the internet. Databases can stay in private subnets with no public IP addresses, but they can still communicate securely with app servers inside the same VPC. Public subnets can host things like web servers that need internet access, while private subnets hold internal services or databases that must stay hidden. Now let us understand the key concept of a VPC. We have subnets, which can break your VPC into smaller IP ranges, like one for web servers and one for the databases. This separation helps to keep the workloads organized and secure. Next, we have route tables. The route tables decide where the packets must go, whether to another subnet or out to the internet. For example, a web traffic might route to an internet gateway, while the DB traffic stays internal. An internet gateway gives public subnets and internet access. A net gateway lets the private subnets reach out for subnets without being exposed to the internet. We then have security groups, which act like firewalls for individual resources. The network access control list apply at the subnet level to control traffic in and out. Lastly, we have an ALB, which is an application load balancer. The application load balancer spreads incoming requests across multiple servers. This ensures that users always hit a healthy instance, improving availability. Now let us take a quick look at the architecture that we are going to build. We will have two availability zones, EU West 1A and EU West 1B. In each zone, there's a public subnet that hosts the EC2 web servers and a private subnet that hosts the RDS databases. The web servers are going to sit behind an application load balancer, which connects to the internet gateway so that the users can access the app. The RDS database is going to stay private, no internet access, and they will only be reachable from the EC2 instances through the security groups. Now, this setup is going to ensure redundancy, scalability, and security. Now, let us break the flow of this architecture step by step. Firstly, a user makes a request from their browser. It first hits the internet gateway. From there, the traffic is sent to the application load balancer, which decides which web server to use. The application load balancer then forwards the request to one of the EC2 instances running in the public subnets across the both availability zones, which is EU West 1A and EU West 1B. Then, when the web app needs the data, the EC2 connects securely to the RDS databases inside the private subnets. No direct internet exposure. Then the RDS sends the data back to the EC2 instance, which then responds through the application load balancer, and finally the result reaches the user's browser. We will start by creating our own private network. Every resource that we will launch, it will live in this space. I'm going to go to the VPC dashboard. Then I'm going to click Create VPC. I'll choose VPC only because we want full control over the network setup. If we choose the other options, AWS will automatically create the subnets, the gateways, and the route tables for us, which will then take away the flexibility. By starting with just the VPC, we decide exactly how our network should be structured. And for the name, I'm going to use my high availability VPC. Now for the CIDR block, it is a common practice to start with 10.0.0. 10.0.0 by 16, as it gives us a large range of IP addresses to use within our private network. Then I'm going to click create VPC. Now that we have our VPC, we need to divide it into smaller sections called subnets. The public subnets will be for resources that needs to be accessible from the internet, like our web servers, and the private subnets will be for resources that should not be exposed to the internet, like our database. I'll go ahead and click create subnet and choose the VPC that we just created. So we will place them into different availability zones, EU West 1A and EU West 1B. This will ensure that even if one of our data center goes down, the other one is still running, so our architecture remains highly available. I'm going to name it the public subnet A for the first one. Now we've created our 4 subnets. Our public subnets exist, but they can't talk to the outside world yet. We need a component that will allow traffic to flow in and out of our VPC. Right now, even though we have the public subnets, they are not truly public. By default, nothing inside a VPC can talk to the internet. So that's where an internet gateway comes in. An internet gateway will allow resources in our public subnet to reach the internet. I'm going to click create an internet gateway, and I'm just going to name it my internet gateway. Now we need to attach it to a VPC. Then I'm going to click actions, attach to a VPC, then select the VPC that we just created and click attach internet gateway. So once we've attached our internet gateway, this doesn't automatically give us the internet access. We also need to update the route tables so that they can send traffic through this gateway. So I'm going to go to the route tables. We will create a route table from our public subnets, which will instruct all internet-bound traffic to go through our internet gateway. So creating an internet gateway was only half of the job. Our subnets still don't know how to use it. If we want the traffic to reach the internet, we need to add a new route table. So we will name it public route table and select the VPC that we just created. Then create the route table. On the routes tab, we're going to edit the routes. So we're going to add a route. For the destination, you're going to choose anywhere. And it's going to target the internet gateway, then the one that we just created, and click save changes. Now we need to associate this route table with our public subnet. So subnet associations, edit subnet associations, then you're going to select all the public subnets and click save associations. So this separation is what makes the subnets behave differently. They are in the same VPC, but they have different routing rules that define whether a subnet is public or it's private. Now that our network can talk to the internet, we need to control who can talk to what inside it. So we will use the security groups. They control inbound and outbound traffic. We will create 3 different security groups for our applications. Create security group. So the first one, it will be the web security group. So description, let me say web, and choose the VPC that we just created. Then on the inbound rules, we're going to add a rule for SSH and another one for HTTP. For the SSH, let's just choose anyway. For the HTTP, let's also choose anyway. Then click create security groups, and we need to create another one. This one is for the database. Select the VPC we created. Then for the database, we need an inbound rule for the database, and we're going to use the Postgres engine. Source, so this is important. The source here, it must be from the web security group that we just created. Then click save rules. Then the last one is for our load balancer. Then here for the inbound rule, we're also going to allow HTTP from anywhere. So this will allow the public to reach our load balancer. Then click create security group. Now that we have these three security groups, the public can only talk to the load balancer. The load balancer only talks to the web servers. The web servers only talk to the database. We are now ready to launch our web servers. Remember, we need one in each of our public subnets to create higher availability. So I'll go to the EC2. Then I'm going to launch our first instance. Let's call it web server A, and leave everything as the default. Go to the network settings, make sure the correct VPC is selected. The subnet, it must be in public subnet A, and also auto assign IP, it must be enabled. Then you must use the existing security groups that you have and choose the web security group. Then click launch instance. For the key pair, I'll use my key. Then I'm going to launch another instance. This will be my web server. To the network settings, click the key. This will be in public subnet B. Enable, choose the security group. Now both of our instances are running, so we need to install web server on each to test our setup. Now that we've created our EC2 instances, we need to connect and create test pages for both server A and server B. I'm going to start with server A, and I'm going to copy the public IPv4 address. Then I'm going to paste the IPv4 address. Now I've successfully connected to the EC2 instance. Then I'm going to install web server. Now I'm going to start the web server service. So this just created a simple HTML file in web server A. Then I'm going to do the same for web server B. Then I'm going to install the web server again. I'm going to pause the video and do the same for B. I've created the same for web server B. Now we need to distribute the traffic using an application load balancer. So I'm going to go to the load balancers. Now that we have two web servers, one in each availability zone, we need a way that will make them work together. So if we don't use a load balancer, the users will only connect to one server at a time, meaning if one server goes down, the site will go offline. Or if many people try to hit one server, it might even overload. So this is why we need an application load balancer. This is going to sit exactly in front of our servers. Then it's going to take all the incoming traffic and distribute it evenly across them. I'm going to choose the application load balancer and click create. Now we're going to name it my high availability ALB. Under network mapping, we're going to select the VPC that we created, and we're going to select all the availability zones, and we're going to ensure that we select the public subnets. Now scrolling down, for the security group, it needs to use the load balancer security group that we created. Then the last thing, it's a target group. Then click create load balancer. We are going to give it a few minutes. Now that is done, let's try and test our application load balancer. So I'm going to go to this tab. Now on the first refresh, it says hello from web server in availability zone A. So if we try to refresh again, it might say availability zone B. So this proves that our application load balancer is working. It's sending our traffic to both servers. So this way, if one server goes down, the application load balancer automatically detects that and it routes all the traffic to the healthy one. So this is what gives us high availability. Now that our web layer is set up and it's highly available, we need to do the same with our database layer. So instead of running our own database on EC2, we will use the AWS service, the RDS. We've deployed 2 servers across 2 availability zones behind an application load balancer. For the database, we are not going high availability in this video, and the reason is multi-availability zones doubles the resources and adds replication overhead. Today's video is about networking, routing, and secure reachability. So you can switch this exact setup to multi-availability zone later without redesigning the VPC or security groups. So I'll show you how to provision one PostgreSQL database on RDS on a single availability zones. And this is going to work on a free tier inside our VPC. It will stay private, reachable, and reachable only from our web servers. I'm going to go to the databases, create database, standard create. Let's name it my DB. The master username is okay, and for password, public access is very important that you choose no here. Then we're going to choose the security group that we created. Let's use availability zone 1A. So I'll wait for the status. Now that our database shows that it's available, I'm going to go inside the database and copy the endpoint. Then going back to one of our web servers. Now I'm going to connect to the SQL. I'm going to connect to the PostgreSQL. So this shows that our connection succeeds. We can do a mini test. So this shows that we are connected to the database. So we just proved that our EC2 web server instance can connect directly to our RDS PostgreSQL database inside the VPC. And I just tested one server. There's no need to test the other server because they are basically on the same network. So this connection worked because of the security group rules that we created. We set the DB security group to only allow traffic from the web server security groups. So the configuration is correct. The database is private, not public. Only web servers can reach it, and those security rules are doing their job. This is the architecture that we built today, a secure, scalable two-tier setup across multiple availability zones. This pattern forms the foundation for most real-world applications on AWS. Thank you for following along. I hope this gave you a clear picture of how VPC networking works in practice. And that's it today from Cloud with Previn. Please let me know in the comments what you'd like me to cover next. And if you enjoyed this, please hit the like and subscribe button so you don't miss the next one. Bye.